Hello, hello, hello. We are back on. This is Erich. Erich is our next keynote speaker. He's from Bitweb, tech lead, and he has a wealth of experience, 10 years in the tech area to share with you today. And he's ready to talk to you about applying infrastructure as code philosophy and talk about great tools related to it. So without further ado, Eri, the floor is yours.
Thank you. Good afternoon, everyone. I hope you're having a great experience here today. And I know that I am. And I would like to thank the organizing team for making it all happen and also for giving me an opportunity to talk about infrastructure as code. So where did this idea come from? A few months ago, I was at a conference in Tallinn, and the speaker asked the audience to raise their hand who practiced CI/CD tools and performed infrastructure as code in their daily basis practice. And out of 200 people that were in the audience, only 3 hands were raised. Mine was one of them, and it gave me a signal that infrastructure as code is something that should be discussed more. So my name is Erich Jagomägis. I work as a technical lead at a company called Bitweb. I've been with the company for 11 years, whereas the company has been on the market for around 14 years. And during this time, we've had ample opportunity to work with wonderful people all across different disciplines and form fond memories, as well as participate in learning opportunities. So what are we actually doing? We as a company focus on web-based information systems. And on the screen, you can see the logos of different technologies that we use, not limiting ourselves to only these, but we don't want to make the screen too crowded. So with the pleasantries over, let's get to the topic. First of all, we need to understand what are we talking about. So let's get our terminology right. Infrastructure as code is a phrase that consists of 2 words, last of which is code. So what is code? No, it's not something you have to crack, and it's not something it's not some form of lead speech. When we talk about code, it can be any machine-readable piece of text that can be given to a tool or a service, and as a result, something productive comes out. Usually, it takes form in some form of action or in creation or creation of some state. When we talk about infrastructure, well, this term has, I've read about it and I've seen many different definitions of the term. I've tried to boil it down as simple as possible for myself, and I see it as anything and everything that makes up a system. So starting at the bottom, there might be a network topology, and on top into that network topology, we want to create our virtual machines. And out of these virtual machines, we want to create a cluster. And that cluster will have to run our applications along with some configuration. And around our applications, there are supporting services like databases and message queues and email servers. Or it can also be our storage for our files or our data. It can be our backup procedures and anything related to security, like firewall rules and access to the services and security groups. It can also be any entry point into our system, as well as load balancers and proxies. So anything and everything is infrastructure. And this makes the discussion somewhat simpler. So what is infrastructure as code? It is a principle where you try to create and maintain your system via automatic processes. And why are we talking about this? What makes it a thing? Well, practice shows that infrastructure as code has some beneficial properties which can save us some time, save our partners, our clients money, and along the way we get to adopt new technologies so we can not become legacy. So first of the points I would like to address is documentation. Documentation is something that is the first casualty when your development becomes fast-paced. As a result, it's not often that I see any documentation that is up to date, that has all the information that I need. So I've often gone to the code to look what is actually happening, how are things actually set up. And infrastructure as code allows me to do exactly that. So first thing, I document, I code, and then I apply it in practice. If you're using your code, you focus on something that you are interested in, and that makes your intent transparent, and it's obvious to see what you are focused on, and everything else that you weren't focused on has become the defaults of the tools and the services that you use. Again, when you're using different tools and services, these tools apply some kind of standard or convention or a language, something that creates a standard inside your documentation and your code by extension. And when you're onboarding new people into your team, and these people are well versed in these technologies that you use, the onboarding for them becomes that much simpler. Like from personal experience, when I'm jumping from project to project in our company, I don't have to know beforehand what the project is actually doing. I can just go in there, I can find with relative ease the point of interest that interests me, and I get the information that I need quite fast. If we are writing code, we usually house it somewhere, we keep it somewhere. I hope that you keep it in a version control system. And once it's in version control system, it gives us an opportunity to keep things transparent. We can see how the changes were made, when the changes were made, by whom they're made. And if you're disciplined, the commit messages are clear, and it's easy to track how your system, how your infrastructure is mutating through time. If you're using CI/CD tools, then these CI/CD tools apply your code via deployments, and for each deployment you can track when it happened, who initialized it, and what was the outcome. You're writing code, you don't write it just to throw it away later or use it once, so you can use it again. And if you write your code well and you make it in a parameterized manner, you can reuse it in a variety of ways. For example, if you're writing a system, it's customary to have multiple environments of this system, for example, testing, staging, and production. It's a good idea to keep these environments as similar as possible, and thus you get the first opportunity to reuse your code. Alas, why the parameterization is important is that you don't want to allocate as many resources in your testing environment as you would in, for example, production environment. So reusability must also come with, your code also must come with some, how do I say, flexibility. Now, when you're working on when you've done working on one project, you can continue working on a new project. So you take your code with you, and you can reuse it there as well. And this is something that I see constantly in our projects. And we also share our code with our members or our team members. And they get to learn from it, they get to improve it, and everyone wins. It's quite important to note here that since we are sharing the code to somebody else, they don't have to reinvent the wheel. They save a lot of time. Thus, they save a lot of resources for the clients as well. And when we are sharing our code between each other, every time I get something for free, I try to improve it a little bit, add some new feature, add something that wasn't done before. And for example, there is an example of this where I was given a code to deploy an application in a cluster that was quite specific, and I got something for free. But it did only deployment. It didn't do much in a sense of optimization. So I did a little bit of optimization, and somebody later came to me and asked, can you give me this piece? And I did so. And the next team took the same template, and they added the possibility to monitor the health of the application in a more precise manner. And again, I got this code change back, and I propagated back to the original author. So we all got 3 distinct features, but we only had to implement one of them. And the cycle of applying, sharing, improving, applying, sharing, improving is a very good environment where you can slowly integrate infrastructure as code as a philosophy. In theory, when you read literature on the matter, there is a lot of coverage about disaster recovery. Well, I guess I've been lucky. I've never had this much of a disaster to recover from. But I can share an example here. At some point, I had a cluster of machines, and these machines had something wrong with their network interfaces, and I had to do a change. By reading the documentation or the reference of the service that I used, they said that I had to destroy these old machines and create ones from new. I had applications running, I had setups done on these machines, so it was a bit scary. So I did the changes inside my templates, and I applied the templates to the cloud provider, and 5 to 10 minutes later I had new machines running with all the applications set up and good to go, and I could easily destroy the old ones. So it kind of proved to me that disaster recovery is possible. So the good properties of infrastructure as code are only as good as the tools are that we use. So we should focus a little bit on the tools as well. It all starts off with CI/CD tools like Bamboo, GitLab, Jenkins, well, the usual suspects. I'm sure that most of you, or all of you, have at least heard about them before. And some of them have a lot more features provided. I want to focus specifically on the feature of the pipelines, where you can define a set of steps or tasks, depending on the tool you use, to define to describe how your code should be ran or deployed. Another good technology is Docker. Can anybody raise their hands if they use Docker today on a daily basis? half, more or less. Cool. Docker enables you to bundle your application with all its dependencies with regards to the host into a single artifact called the image. The recipe for the image is called the Docker file. And once you've built an image, you can upload it into the registry, maybe somewhere in the cloud. And later, in your hardware, you can use that image to create an instance of your application. And this instance is called the container. Why I added this service or this tool to the slide is because it makes your deployment that more uniform. So you can, when you're doing this IaC codes for different applications that you have, you can reuse the same bits over and over because everything is hidden inside Docker. So let's take it a step further. There is a platform called Kubernetes, which allows you to take n amount of machines and m amount of applications. You give them to the Kubernetes, and Kubernetes will orchestrate how these applications should be run on these machines, and it will also configure them in the way that you want. And it will bind them together into specific services. And also, you can describe how the services should be approached from the external network via the ingress. So Kubernetes is one of my top favorite tools to use today, mainly because you can run it basically anywhere, but we'll talk about this later. And it also is quite simple to learn in comparison to some other technologies out there. And it also does a lot of stuff for you for free. For example, it's self-healing. So if your application crashes, it will bring a new instance of your application up. If you are doing an update of your application, it will do it in a green-blue deployment manner. You can centralize your entire configuration inside Kubernetes, so you don't have to keep it local on different machines. And it can also be extended in wide variety of ways to keep your secrets and to do monitoring and whatever else you might come up with. So it's a really, really great thing to at least get introduced in. Kubernetes does things at a specific layer, and some things it cannot do. It cannot do network topology, it cannot do firewall, it cannot do access to your nodes. And if you need a more comprehensive package, then you can take use of today already popular cloud providers. And each of the major cloud providers, they have tools available to deploy your infrastructure. AWS comes with CloudFormation, and in Google they have recently released, I think, Deployment Manager, and Microsoft Azure provides Resource Manager. And basically these tools, they take description of your infrastructure as an input, and they create your infrastructure as a result. Sometimes you might be tempted to keep your application setup or application layer agnostic of the cloud provider. You could do it with Kubernetes, and each major cloud provider has tools available to house the Kubernetes cluster inside the infrastructure quite comfortably. If you want to keep everything agnostic, you can use a tool called Terraform, where you write your code in a specific language, and in theory you should be able to deploy it into any cloud provider out there. Personally, I don't have experience with this, but having heard about it from a lot of people I work with, it seemed like a worthy contender to the slide. The last one I would like to point out is Ansible. Ansible is a very versatile tool. It allows you to write both declarative code as well as procedural. Procedural meaning that you, instead of describing the state of the infrastructure, you describe the steps needed to be taken to achieve the state. And in Ansible, you write something called playbooks, which is another fancy word for a template. And then you can use the Ansible runtime to do your deployments. So I've been doing my rambling enough. Maybe we should take a look at a practical picture. Yes. So what we start off is quite simple. Bitbucket repository containing some files. Each of these files, they describe a certain resource which is part of my infrastructure. So just as an example, I'd like to open up an RDS, which is AWS database. And yes, these templates, they are for CloudFormation in AWS. So if I look here, I have the mappings describing different properties that are of interest to me. For example, how many maximum connections should my database support? How much storage should be allocated? And this is all for the staging environment. If I have a production environment, I have a different set of parameters. And this gives me this documentation part. I know exactly what is being done. Then if I want to go deeper, I can see different pieces of the infrastructure being created. For example, here's a security group controlling how my database will be accessible. A bit lower, we can see the creation of the DNS record inside my private hosted zone. A bit lower, I can see that there is a monitoring role being created for the monitoring service to access my database and collect some useful information. There is also a description of in which subnets in my network should my database be created, as well as the database specific parameters inside the database. For example, how much should the query wait before timing out, or how many max connections are supported. Encryption keys for the data, not much of interesting. This piece here is cool. Not many tools I see that allow me to create the secret for my database before I create the database itself, and later like bind them together. In CloudFormation you can do that, and the secret itself is stored into the secrets manager. I can later reuse it if I want to access the database, or to then start working on the inner state of the database. And all those resources are bound together into this final resource called DB instance, which describes the database itself. And this is just one file and one set of resources. There are other ones. I will not be going into other ones for your sake. But for each file in here, if you go into the AWS console and I open up CloudFormation service, there is a corresponding line here describing how the deployment of that template went. So, for example, if I open the same RDS again, I'll make a bit more room on the screen. I can see all the events that happened during the deployment. I usually go here when something goes wrong. I can see all the resources created during my deployment. and maybe some other outputs and parameters that were fed in. Now, if I go into the RDS tab inside AWS, I can actually take a look at my own database instance. So here it is, nicely purring along, not doing anything. Cool. Well, what did the other resources create? For example, they created a virtual private cluster, which also houses the same database instance. So if I go here and I look at the resource map, I can see that my VPC is created. It has 4 subnets across 2 availability zones. They are bound together via a routing table, which is also described in the template, as well as there are ingress and egress into my private cloud. So this is the level of detail you can do stuff with CloudFormation. So if we go further, we have EC2 instances created, completely managed, and these instances, they are created by a cluster. The ECS cluster is an answer from the AWS to Kubernetes. So it is capable to spin up machines when it runs out of resources, and it houses my applications. So in given example, I've created 2 instances of my application. They are running somewhere on those machines. And there also exists a load balancer between those 2, also defined with code. So if at the end of the day, if I land here and I do a few refreshes, yes, we can see the IP is changing. Well, for the application, I picked just a simple recognizable Nginx demo app. So that would pretty much conclude the demo. And if the kind sir would allow me. Yes, thank you. So I've been talking about all the good points coming from this infrastructure as code, but is it really so glamorous as it seems? Well, in practice, there are some challenges we have to address, and maybe we should. So the first and foremost, there is a significant learning curve when delving into all these new tools, new services, new languages, syntaxes, and whatnot. And there is also a significant shift in your mindset when you're doing these things. You always have this temptation to do manual labor, but you should try to hold yourself back and not do it. And as a result, at some point you will start feeling confident, and you will start growing your repertoire and tool set. Stuff usually, if it can go wrong, it will go wrong. There can be unexpected behavior at times. It really depends on the tools that you choose. I would suggest you choose tools that can be trustworthy. And well, for example, I can speak about a case where I had a database instance and I had to update some feature on it. And I read the documentation how to do the change, but I forgot to read the disclaimer. And what happened was the disclaimer said that this change will destroy my database instance and create a new one. Well, all being said and done, I look and I have a new database instance and no data. Well, I thought to myself, okay, I'll take my backup and I'll restore it from there. Well, I didn't read the documentation for that as well. Apparently, in AWS, if you delete an instance, all the automatic snapshots get deleted along with it. So you have to do manual snapshot as well. And that was a significant lesson to learn. As it turns out, there exists a property called deletion prevention equals true, which allows you to avoid this kind of mistakes. But luckily for me, I was able to experience this in the testing environment. And by the time this change made it to production, it was done the right way. When you are doing infrastructure as code, you shouldn't feel like you have to automate everything. Not everything can be automated. For example, for the same demo that I did, I had to create the account in AWS manually. So don't try to automate this part. And when you're using different cloud providers, you'll discover that some things like maybe private keys, private key generation, or some certificates are done manually only. And it's okay to do these parts manually. You document them, these steps in the README, and go along. Happily, these steps are usually one-time setups, so they don't interfere with your daily working routine. One thing that infrastructure as code will not solve for you is maintenance as code, and all the APIs that you use have to be maintained, and they have to be updated, and this is true when you're doing things in manual fashion all the same. But yeah, this problem doesn't go away. But in my personal experience, I feel like it is a bit easier to do when you're doing automated processes. So my general takeaway from this all is that you should approach this with small bites, like find a small thing that you can do and try to automate it. If it works, start improving, start doing this cycle, share, apply, improve. And maybe a year or two down the line, your entire infrastructure is automated, and maybe you will not even notice it your client will not notice it on the bill. And overall, there are a lot of tools. This landscape can be quite mind-boggling. So try to take it easy, be adventurous, and yeah, try it out. So quality assurance. No, it's the point where you can actually ask questions.
Selge.
Crickets.
Saab lihtsalt.
At least one question. Well, if you are too shy right now, maybe you could...
Hi, sorry.
Yes.
I have a question.
Aha.
What about testing infrastructure as code? Like with unit test or something, I get that you have like testing environment, staging, whatever, and first you can make your breaking change and test and manually verify it, but are there like possibilities to do it automatically? Have you implemented something like that?
Well, we are writing automated tests for our applications, as well as we are writing end-to-end tests for the entire system. And these tests are run like every night. And right now we are testing the infrastructure in a way that the end-to-end tests try to use our product via Cypress or Selenium or whatever the tool they use, the QA team. And if something is wrong, I hope that this is like enough to also verify that the infrastructure is like sound.
Thank you.
Do we have more questions for Erich? I see a hand. Great.
So thank you for your talk. What was the most difficult tool for you to learn, or how long did it take for you to learn all this automation?
For me, the most complex part was like understanding the basic principles when you are interacting with the cloud provider. So the first tool that I was learning was AWS CloudFormation, and even though it wasn't so hard, like technically, it was a significant challenge for me in terms of like a mindset. And after I got through it, I started learning Microsoft Azure, and that went like a lot simpler. Although it had its own challenges, specifically technical challenges, but it was like significantly simpler. And before any of that, I was learning Kubernetes, and again, the mind shift was the blocker. Like technically, everything there is quite simple, but the mind shift.
Thank you.
Awesome. Do we have some more curious minds who want to dig into the mind of Erich?
Well, regardless, we have a booth. I will be there.
Hey, hello. Sorry.
Yes.
I just want to ask, not really a topic, but you seem to be really happy with Kubernetes. How about Docker Composer and Swarm? Any experience with that?
Well, Docker Compose is quite limiting in its functionality. Docker Swarm is a close relative to Kubernetes. And in practice, I have very little, like, how do I say, contact with this specific tech. But as much as I've seen, it did seem like working. It did seem like pleasure to work with. But I simply don't have the experience to compare like Docker Swarm against Kubernetes. As far as I've read in the literature, they seem like really, really similar.
Any more comments, questions related to the topic, related to the keynote? Well, as Erich said, Bitweb has a demo booth in the demo area. You have 1 more hour or a little bit less to collect stamps. So actually, maybe you can help out the participants with getting more stamps on their card. But thank you very much. And let's give an applause to Erich.